Okay, electrical interface to the freezer. If you remember that mechanical device I showed in the other video, that device completely cuts power to the freezer or completely restores it depending upon the temperature inside the freezer. Works fine, no complaints, but I want for example, I want to have continuous use of the lid light. I'm going to have a fan in there that I'm going to want to be running even though the compressor isn't on. And of course I have my digital temperature controller, which always needs to have power. So what I need to do is figure out a way to only cut or restore power to the compressor while still having electrical power for these other things. And let's show you how we're going to do it.
So I put together a quick and dirty schematic, something I just kind of threw together in Paint. It's certainly not to any schematic codes. But what we have is the line coming in from the wall. You've got your green is ground, blue is neutral, red is hot. You notice that the dome light connector and the temperature controller connector are always live because they are in line prior to any switches. So what happens is you get a signal coming in from the temperature controller, comes through this little plug here, energizes the relay. When the relay is energized, it closes this switch, and by doing so sends the 120 volts up to the plug that controls the compressor. And that's really all there is to it. There really isn't a lot of complex wiring here. It's just you got to make sure you get all your signals right.
Okay, here's the interface for the compressor, dummied up on the bench. We've got our solid state relay with the switch circuit. It's going to come in on this 1/8 jack and essentially activate the switch down here, which will turn the relay on. And up here we have, this is the plug that's going to go into the wall, and we have from that plug we have the hot side of the 120 volts coming into one side of the relay, and then when the relay is activated and this switch closes, it's going to take that 120 volts and send it into this plug here. Now the freezer is going to plug into here. So you plug the freezer into here, plug this into the wall, and every time the relay is activated, it's going to take the wall power through these contacts and activate this plug, which will turn on the compressor in the freezer. I'm pretty fortunate in that it seems that all of these freezers are made probably in the same factory somewhere in China. The old keg freezer that failed on me, I cut out the entire wiring harness and saved it in case there were some parts that I could salvage. And why that's an advantage to me is this connector here is the freezer side connector for the lid light, and there's a wire that comes out of the lid and goes into that little mechanical compartment, and on the end of that wire is a connector that mates with this and thus powers the lid. It turns out that these connectors are exactly the same. I have no idea how old that other freezer was. It's at least 6 or 7 years old, but yet they use the exact same connectors. So I salvaged this connector, and I'm going to use that as part of my scheme to make the lid and collar easily removable, because now I don't have to cut or otherwise modify the connector that comes out of the new lid. So what I'm going to do is I'm going to take this connector. I have dozens of these computer type cables. I just, for whatever reason, I have a big box of them, and whenever I need a bit of wire or a neat looking cable setup, I just grab one of these and snip off whatever end I'm not using. So that's exactly what I'm going to do. I'm going to take this connector here, I'm going to mate it with this cable here, and that's going to be the new freezer side connector for the lid light. Okay, I have the freezer up on a folding table for easier access to the mechanics. Take a quick look around here. I haven't done anything in here yet, so this is just to kind of show you what it looks like before mucking about with it. Ideally, what I'd like to do is I'd like to get the SSR mounted up in this corner up here. That'll get it way out of the way of everything. It'll get it nice and far back in so that any potentially exposed 120 volt terminals will be really difficult for people to stick their fingers into. The problem with that idea is that it's a little tight. My big fat hands have trouble getting in there, and might be a bit of a pain to get a drill bit back there to drill the couple of holes I'll need to drill. So we'll just have to see what I can or cannot accomplish. Worst case, there's plenty of open volume in here to mount everything. There's a nice rigid backbone kind of brace here that I can bolt the SSR to, and lots of open volume that I can have wires hanging out in. I'd rather not do that, just because on the odd chance that myself or someone else needs to kind of fiddle around back here, you might be close to some exposed 120 volt terminals. In the grand scheme of things, that's not really the most important thing to me. You know, if people stick their hands in there, they get what they get. So that's it. I don't know how much of the actual work I'm going to film, because really that's just going to consist mostly of me dropping tools and swearing. If it looks like there's something that I really need to film and point out, I will. Other than that, I'll see you in a moment to show you the finished interface. The wiring is done. Let's see if I can give you a look at what I did. So I was able to get that solid state relay in the corner like I wanted to. You can see we've got a couple of screws holding it in place. Down below are the terminals that you send your power to activate it. Up above is the actual switch. You can see on the right, that is where the 120 volts is coming in. So one of those wires goes right out to the wall plug, and the other two power a couple of other items, which we'll show you in a moment. And then, of course, when the relay is tripped, the power jumps from here over to here, and then powers this. Let's see if we can see it. Powers, there you are. Powers that gray outlet, which that's the switched outlet, and the original plug for the freezer is plugged into that. So because the original plug now only powers the compressor, whenever this gray plug is hot, the compressor is running. And that's the basis for this whole project, is that the temperature controller turns on the relay turns on that gray plug, and the gray plug turns on the compressor. So other stuff we have, let's see how we can do this. Sorry about the jumpy video here. This orange plug here is not a switched plug. It's always on when the new freezer cord is plugged in. This is always energized. And what this one's going to be doing is powering the fan and the temperature controller inside the cavity of the freezer. And then over here we have the replacement receptacle that's going to be powering the dome light. I don't know if you can see it, but down here, yeah, you can sort of see it. Down here we have the original power for the dome light that the freezer came with. I just put a little plastic bag over it so that nobody would use it. And now this new one becomes the dome light. And then what else we got? This is the 1/8 jack that is going to receive the signal from the new temperature controller. And then when the temperature controller energizes this jack, that will put power across these two terminals, which will then trip the relay. And that's about it. Let's see. You know, this is, where is it? Here it is. This plug here is the plug that I picked up from Home Depot. Just picked up a plug end. And this is the plug that now goes into the wall. So, let's see what else. You can see in the cavity, here's some of the wiring that I ran. I put some little clips on that back wall so that I could run the wires a little bit more cleanly so that things wouldn't be just hanging around. Got a clip there, some zip ties, just to make the whole job a little bit neater. So, okay, that's what it looks like. It's certainly not the neatest wiring job I've ever done, but you know, once I put the cover on, all this stuff's going to be invisible. So there you go. Okay, one other thing that I did want to point out. If you look, you can see here's one of the plugs that's always energized. This is the one that controls the temperature, that provides power to the temperature controller. And you look over here, you can see the gray plug, that's the switched plug. What you notice is that both of these are female. They are receptacles. It is a rule of thumb that from your source of power, you maintain female connectors. And what you are powering, the thing that does not normally have power, can be male. And the reason being that if this, for example, was a male plug, and it was energized and it had power to it, it would be easy for you to short it out against something. You might touch it. You can see down here, you know, obviously if this plug had power to it and was just sitting there, there's a real danger that, you know, sparks would fly. So, general rule of thumb, from your source of power is female, and then the thing that you're powering is male.